All right, we're ready for our second video, and this one is solving two-step equations with negatives. So this one is going to focus on where you've got all kinds of different negatives in your problem and different ways of attacking those problems and watching out for those negatives. The first thing we need you do is, if you notice, I totally messed up your essential question in your note packet, and it has something to do with fractions and percents and nothing that has to do with equations. So please cross that one out and replace it with this essential question. This will tell us who's actually paying attention and listening to their video. How do negative numbers make solving an equation more challenging? That's the essential question we want you to fill in.
All right, we are going to follow the same steps we did in our last video. We're just going to watch out for those negatives and how it's going to affect us in solving the equation. So we've got negative 8y minus 16 is equal to negative 24. We're going to start off by adding the opposite of a negative 16. So plus 16 on both sides, please. Simplify, cross that zero pair out, and negative 24 plus 16 is going to give us a negative 8. So we have negative 8 is equal to negative 8y. We want a positive y, so we're going to divide both sides by a negative 8.
So we want the negative and the 8 to cancel each other out with that dividing.
So a negative 8 divided by a negative 8 will give us the positive y we want. On the left side, we have a negative 8 divided by a negative 8, which is going to give us a positive 1. So checking our work, negative 8 times 1 is negative 8. Negative 8 plus a negative 16 is going to get us the negative 24. That's on the left side. So we balance.
So when you're doing that check, we want to actually see you doing the math step by step to actually check see that you do get that correct answer. Our next one up here, negative 7 plus w. Remember that fraction bar is really code for divided by negative 4 equals 5. This one's a little tricky, so pay close attention. Always focus on the variable. What did they do to the variable? Well, they added a negative 7. So we want to do the opposite. The opposite of addition is subtraction. But we want to do the same number that they were adding. They were adding a negative 7, so I'm going to subtract a negative 7 on both sides. And hopefully your brain immediately is going, oh yeah, if I'm subtracting a negative, I want to change that to adding the opposite. So in this case, I'm really adding a positive 7. 5 plus 7 is 12. My negative 7 and my positive 7 turn to 0, so they drop out, and I'm left with w divided by a negative 4. And now I can finish solving it. If they're dividing, I want to multiply, but I want to multiply by exactly the same thing they were dividing. They divided by negative 4, so I want to multiply times negative 4. I'm going to do that on both sides. W is equal to 12 times negative 4. If one of them is negative, it stays negative. 12 times 4 is negative 48. A very quick check. Negative 7 plus negative 48 divided by negative 4. I'm rewriting the whole problem, and then I'm going to do the math. Negative 48 divided by negative 4 is positive 12, plus a negative 7. Different signs subtract, and I get 5 for an answer. But watch those negatives all the way through the problem.
All right, what do we got?
Lots of negatives.
If you are subtracting a negative number, change it to the opposite right away.
So when you notice both subtracting and a negative, here we want to get rid of them right away.
So we're going to rewrite that equation to say negative 3x plus 9 is equal to 21. Now, adding a 9, we need to add a negative 9 or subtract 9 from both sides. Thank you. Simplifies to negative 3x equals 21 minus 9 is 12. Can you get that out of there? Thanks.
My bad.
Multiplication opposite is division, so we're going to divide both sides by the negative 3. Take the negative with us to get a positive x. Simplify gives us...
So think of the 3 and the negatives are kind of canceling each other out.
X is going to give us a negative 4 because I only have one negative in that division problem. So rewriting negative 3 times a negative 4 plus 9 is equal to 21. So that does give us positive 12. I don't know what you're writing. Plus 9, which does indeed give us 21.
All right, next one, 5x minus negative 4. So as soon as I see that subtracting a negative, I'm immediately adding the opposite or adding a positive. And then I just follow my steps for solving a two-step equation. They added 4, so I do the opposite or the inverse, which is the subtract 4. when you saw me write that -4 under my -11, a little alarm should go off in your head. Subtraction and negatives don't get along, so we want to change this into adding the opposite right away. -11 plus -4 is -15. Here, a +4 and a -4 or -4 turn to 0, so I'm left with 5x. Then 5x means they multiplied by 5, so I want to do the opposite, which is to divide by 5. 5 divided by 5 is 1, or just x. -5, 15 divided by 5 is -3. And then a quick check, 5 times -3
-15.
minus -4. So that becomes -15 plus a +4, which really is -11.
Good job. Moving on. What, we got some fractions? No. When the variable is being subtracted instead of the constant, change the subtraction to adding the opposite. So this time they want you to rewrite the problem instead of 9 minus 2x as 9 plus a -2x.
So in that very first problem we did, we were okay leaving it as subtraction and just doing the opposite. But when that subtraction's in front of the variable, we have to change it. We don't have a choice because we want to know that that 2 is really a -2x.
First thing we want to do is that's a -2x plus 9. So to get the 9 on the other side, we have to subtract 9 from both sides. Simplifying it, we are now going to bring down the -2x. Simplifying on the right, 26 minus 9 is going to give us 50.
And it's going to give us an ugly 17.
17. What did you do here? Divide by -2. We're going. Divide.
This one's not going to come out nicely
-2.
because I didn't check my work ahead of time.
X is going to equal
It's going to be a negative,
8,
and then
8.5. How are you going to have them write it? Leave it like that?
8 1/2, because 2 goes into 17 8 times with 1 left over. For the most part, our answers are going to come out to be nice, neat numbers, so this isn't going to happen very often. I obviously didn't check my work carefully ahead of time to make sure that this was going to divide out nicely for us.
But further check, I wouldn't mind if they left it as 17 over -2 because you're about to check that right now, or no?
Yep. So when you check it, use the improper fraction. So we rewrite it as 9 minus 2 times -17 halves.
Okay, so we're going to do that multiplication.
So we do our multiplication.
-2 over 1 times a -17 over 2. The 2's are going to cancel out.
So I can divide out those 2's.
A negative times
A
negative is a positive.
So I get positive 17 plus my 9 really is 26. I promise they normally will come out a little nicer than that for us.
But you still have to work it through and make sure that you didn't make the mistake, that the mistake was in the problem.
Okay, for this next one, always focus on the side where the variable is. So I want to deal with the right-hand side. When I see subtraction in front of the variable term, I know I want to change that to adding the opposite. And now I want to undo everything that's over here. So they added 8, so I'm going to subtract 8.
Ooh, fancy.
8 minus 8 turns to zeros, drops out, and I'm left with my -4x. But notice on that left-hand side, subtracting from a negative number is not going to go well. We're going to make lots of mistakes. So change this to adding the opposite, and we realize it's really -8 plus -8, which is -16. Same signs, add and keep. Go back to your x. They multiplied by -4, so I'm going to divide by -4. And I'm going to do the same thing on both sides. Again,
So
I want
x is going
everything to drop
equal
out except for the x.
+4.
And I get a +4. Quick check, 8 minus 4 times 4 is 8 minus 16, which is really 8 plus -16, which gives me -8. That's what I wanted up here, so I know I am good. All right, just about done.
When there's a negative in front of the variable, that's like having that invisible -1. So we need to make sure that -1 is written into the equation so we can divide by the -1 when we get there. So first thing, we're going to get rid of the +8 by subtracting 8 from both sides. Simplifying it, we're going to rewrite it as -1x is equal to 23. So dividing both sides by -1, we have to end the equation with a positive x. So we have to do this last step. X is equal to -23. When we check it,
It's the opposite of -23.
which is going to give us positive 23,
Those cancel out to be positive.
which gives us the 31 that we want. Sorry. Dang.
So again, when you see a negative in front of the variable, if there's no coefficient, fill in that 1, because we don't want to, otherwise we're going to end up with the wrong sign on our final answer for us. Here they added a -9, so I'm going to do the opposite, which is subtracting a -9. I got to subtract the same thing that they added, but I'm going to do that on both sides. You should immediately be going, oh, I'm going to change that to adding the opposite. I don't like subtracting a negative. -6 plus +9 is +3. -9 plus a +9 turns to 0, so that drops out. And I'm left with -1x. Putting in that 1 reminds us that, oh, I do have something in front of x I have to get rid of. They're multiplying times -1, so I'm going to divide both sides by -1. And really all that does is it just changes the sign of the other side. It finds its opposite because we divided by a negative. So x is equal to -3. A quick check, -9 plus -x, which is a -3. A negative, think of that as the same thing as a positive. They kind of undo each other. -9 plus +3 really is -6. So I know I am good. So lots and lots of negatives to be watching for all the way through them.